Yeah. So about 6 years, and I use dtrace literally daily, and literally daily on production systems. Give you some idea of how often. Last year I traveled 46 of the 52 weeks during the year. In fact, over Christmas break I took 2 weeks off. Continental called me to make sure that everything was okay. So you know you've got a real big problem in doing that. And generally it's more than one customer a week. There are rare occasions when it's not. In terms of systems that I've used dtrace on, the vast majority of them are true production systems, things, financial services like exchanges, banks, then there's telcos, pharmaceuticals, all sorts of different things. Just a few weeks ago, I was looking at one of the DNS servers that served the entire eastern seaboard, 50 million plus users. So they get down and all of a sudden it makes people really mad. In the 6 years I've been in dtrace in production, I have yet, and it's all going to come to an end very almost like that, I have yet to actually cause an outage on production.
Oh, don't say that.
That's obviously a testament to exactly what Brian was trying to do, which is to ensure that dtrace is used in production systems, because the assumption that most people don't have good test harnesses for development stage and UA environments is completely true. So being able to use dtrace in production is an absolute necessity. In terms of war stories, I have absolutely many. So we can do things like whose line is it anyway style. Somebody can shout out a piece of software, or
can we shout out greatest hits?
How about get in?
Get it. Carlo, get it.
We've got a request for get in. So this is a financial services customer. They have applications about 1.2 million lines of C++ code. The vast majority of it developed in the put something in front of that since I don't. Sorry, turn the guy out. I want to turn it off. It'll cool down. You won't be able to turn it back on. Just put something in front of it. Okay. So 1.2 million lines of C++ code, and the vast majority of it done between 92 and 94. Their current staff, the person that's been there working on that project the longest, was 6 months. So obviously nobody with really good history in the application. So obviously doing code review on this application is pretty much out of the picture. And the application is responsible for doing a lot of stuff, Monte Carlo simulation being at the real core of it. So they're looking for some pretty significant performance gains because as the models change, their run times are getting longer and longer. So we get the application currently we're running at this time on Solaris 8, we put it on Solaris 10, and obviously using dtrace to look at the application, which is going to be significantly easier in the code review in this particular case, obviously. So we start the application. The first thing that pops out is that they're making many, many millions of getting NV system calls, which seems quite odd for an application that should be doing a lot of exponentiation and log, and et cetera, et cetera. So we obviously grab a use stack at that particular point. We see where it is. Now, instead of having to go search through, or do code review on 1.2 million lines of code, we go straight into the method. It happens to be making getting a V call. We look, it's in the hottest portion of the calculation that we're doing for the Monte Carlo simulation in a very tight loop. And we find the getting a V system, or getting a V call, and the line directly above it is a comment that said, remove this line prior to deploying in production. So all it was doing was looking for the environment variable debug. And the reason for this is that we print out a bunch of mumbo jumbo as to the the iterative passes through doing this. But in looking at it with their traditional tools, they were so focused on it's our algorithm is the problem. Because all we're doing is the algorithm thing. Because in this particular method, it's like take the values and then go apply this, and then getting a default. So they're looking at all the math that they're doing and not. With dtrace, it was easy to see something's happening that really shouldn't be happening. So the whole thing from start to finish until we commented out the line of code as instructed to do was about 5 minutes, and it netted about 67% improvement in performance.
How many percent?
67. And so the interesting thing about that, and I do have a blog now, is at foresightsunsolutions.com, you can find it. But the interesting thing about that, if you look at the vast majority of the cases, we look at applications in production, the fixes are generally like 10 lines of code or less that net you the biggest gains in performance. Very rarely is there, we have to re-architect the application to affect change. So that's the good news.
Your Java dtrace challenge. You want to talk about the Java one?
Yeah, so the Java dtrace challenge, not going to do it this year, but I did it for the previous 3 years of Java 1. which is we have a little pod, I stand there. You bring me your Java application. If we can't make it faster in an hour, you get an iPod. We looked at 50 some odd applications and gave away one iPod to a guy who brought us an application of 200 lines, including 178 of them with comments. That basically just did in a loop an MD5 hash of the previous MD5 hash that he'd done 100 times. And so we sent him an iPod. And the interesting thing was the marketing guy that was responsible for sending the iPods. Having great, just said I cheated at the Java one. And preloaded it with music like "You're cheating hard." The really interesting thing about that, in my last blog entry sort of talks about this a bit, is that of the applications we looked at, probably only like 3 or so had ever previously run on Solaris. These were all applications that were deployed on Windows or on Linux. And they brought them over and said, let's see if it runs. It did run, fixed it to Java, and then we did the analysis from there. So, very interesting that, dtrace really acted as just a tool there where we were able to take applications over and do the analysis on those.
You talk about roadway and just because this is an important case for the history of dtrace, the program trading app.
Which one?
This is the one in Canada. The roadway single lock, the mallet.
Oh, it's got tons of those.
Yeah.
Roadway is just shoot, fish, and where. So roadway, C++ people, anybody that's used it. The older version of roadway that the Sun compiler uses by default is plagued with these wonderful global locks and using full-blown utexes for things like reference counted strings. And it gets actually worse. So you allocate a string. At the time you allocate the string, it mutex an if. It then mutex locks. It then increments a counter. Mutex unlocks. And then generally these strings go away very fast, and so you get the mutex destroy at the end. Actually, you get the mutex lock, decrement the pointer, hit 0, mutex unlock, and then mutex destroy. And so it does this for every string. You have these applications that they're just making massive use of strings inside of C++. And so these locks are just terribly high. The interesting thing is when you build your same application on Linux, it actually defines to use atomics as opposed to full-blown mutexes. And then with some crafty work, you can do the same thing in Solaris, or you can use the new roadway 7 versions, which is, so we have the dash library. It'll come to me in a second. There's an option you can use to do the roadway 7 that uses atomics as opposed to full-blown mutex. But speaking of locks in general, I think one of the least used and most important dtrace uses that's out there is clockstat next to Mr. Adam Leventhal. But people fail to use it. I mean, especially on today's systems where you have a lot of CMT or big systems, lock contention tends to be one of the biggest issues you run into. And clockstat can very quickly, in a matter of seconds, take you to huge scalability problems in applications. One of the ones I just did maybe a couple of months ago. I had a customer. I told them that their biggest problem was lock contention in the application. They said there's no way it's possible. So we argued for a good amount of time. And so finally, they got this brilliant idea and said, okay, y'all start the application, and then you have a transactions per second monitor. And so we're watching that, and I said, okay, tell me if it gets better or worse. So I run a command, and I'm like, oh my God, we just doubled performance. And so they're very excited, and what did you do? Well, offline capture CPUs. So the lock contention is bad enough, we're fighting for that E-cache line. The bigger box you put it on, the worse it's going to get, and the scalability problem. So by taking away for the CPUs, we cut the lock, because the number of people who can be depending on the lock in half, performance got significantly better. But clockstat makes it very easy to see these types of things. So clockstat is another really cool feature.
Joe, what are some of the higher level problems you see most frequently? Like notify all is definitely.
Yeah, notify all is higher level.
When you mention that problem, what are some other problems like that? What are the patterns that you see a lot?
So the biggest thing, notify all, people haven't seen I'm this big advocate against the use of notify all in Java or con broadcast in C or CD broadcast in the kernel, which things just just traditional thundering herd problem. So that's one of the big ones. The other one's obviously lock contention just in general.
Can you actually explain that problem slightly more detailed? So because you may not be familiar with it, why should I not use notify all?
So what a lot of people do is they'll have an application, say I'm pulling data in off the network, right? And I've got a worker thread pool that's going to deal with the data. Guy reads it off the network, and then we have a condition variable that we're going to signal on and say, okay, there's a unit of work to do. And so rather than just doing a notify, which will wake up the next thread out of the thread pool waiting on this. They wake up all threads in the thread pool. And so one application I looked at had 3,000 working threads, which is a pretty significant number of threads, especially considering they were on a 16-bit machine, but whatever. But you know, the fact that they were doing a notify all put 3,000 people wanting to get on CPU simultaneously, which is kind of a bad thing to do, right? So simply deleting 3 letters, the all, and changing to a notify, performance went up substantially, machine utilization substantially.
Do you pick that up with the scan provider? And how do you most often pick that up?
Well, now there's a bunch of different ways, but in the kernel of JWP release all, which is a pretty easy one to grab onto. But generally, what you know, in order to find that is if you can take and say on CPU events and get a timing and distribution of the number of threads that are coming on CPU simultaneously. In that particular case, it's fairly obvious, right? 3,000 people trying to come on simultaneously. But in other applications, you see like 10, they're all getting scheduled very close to each other on these events. And then the other thing that you can do is you can always look at the LWP con signal system call, or LWP con broadcast, right? LWP con broadcast, and you'll see that if you're doing broadcast. In Java, it's a little bit different sometimes because even though they do a notify all in the code, it may signal threads individually, so you get LWP con signal, which you'll be able to pick up on those.
What about the database side? You see a ton of stuff on Sybase, for example. What are some of the common methodologies you see there, and how do you teach us to do?
Databases in general are hard for Oracle and Sybase and DB2 because there's no real support. All the function names are mangled beyond belief. You know, KPR, FE1, 3.
You know what's sad is that in Oracle speak, that's actually not mangled. That's what's
no, in Oracle speak, if you tell them the name of the function, they will tell you exactly what it does instantaneously.
You know what's entertaining with an Oracle engineer? Read them the license plate, and they'll tell you where the license plate is in the code.
So from their standpoint, it's pretty impressive. In terms of database, generally what you have to do is take a map and use the database tools. So like Syscon and Sybase or AWR reports in Oracle. And then what we can do is we can find events of interest in there. Because I don't know if people are familiar with something called METHODR. But there's a book called Oracle Performance written by Kerry Millsap, in which he talks about this method for approaching performance problems in databases, which is actually very good. And it's applicable to things outside of databases. But one of the key things that he has in his book and in a tool that they have, Hot Sauce Profiling, for looking at databases is something called unaccounted for time. From a database perspective, it's very easy to say, we got on CPU, or we were doing this event, we issued an IO, here's how long it took. All those things are very well done, especially in Oracle. They have something called extended SQL tracing, that for every single thing that happens in Oracle, they'll put a timestamp around it. The problem is there's unaccounted for time, in which, you know, either a period of time lapsed between events that shouldn't have been there, or we can't tell what we're doing, all these different things. The beauty part of that is that with dtrace, there's no such thing as unaccounted for time. Which is the presentation I gave at the symposium last year, in which we could take, I could take their tool, where they would report something like 50% unaccounted for time, depending on exactly what they were doing. We could come back over to dtrace and say, here is all that time accounted for. So by putting those two together, we can find stuff.
How much of the time is it going to say was spent by dtrace?
What's that?
How much of the time is it going to tell you it's spent by dtrace?
Very little. I mean, you know, when
Will it be right when it says that?
I
mean, there have got to be parts of dtrace they can't see parts of dtrace.
yeah, no, definitely. And to be honest, for the vast majority of user applications that generate revenue for the company, the amount of interference from dtrace is irrelevant, right? I mean, we're chasing events, for instance, IO, which databases are very keen on. You're chasing events that are millisecond or greater. So even if I hit them with 500 microseconds of latency, I really could care less. So in these particular cases, you know, and that's a perfect one. Is you know, if you look at IO from a database, you look at IO stat, we're measuring from BS strategy to Bible down, right? Which could be very fast, you know, sub-millisecond. And then you look at it from an Oracle perspective and say, okay, how long are our reads taking, or how many waits on writes do I have? And you say, okay, your reads are taking 150 milliseconds. Well, clearly there's an issue there, right? And this is the quintessential problem of the guy that manages the OS saying, no, this is sub-millisecond IO. You're an idiot, go away. Right? It's Oracle's problem. And then Oracle saying, no, we need 158 milliseconds. Well, the cool thing with dtrace is now we can look at all those layers of software that exist between BS strategy and Oracle controlling write or AIO, and quantify it. And so you'll find it in code from Symantec. Is a big place. UFS is a big place. You know, the driver layers, all these different things. And now we can quantify where all that time is being taken and be able to say, okay, here's where we can affect the most change. because we want to get as close to that sub-millisecond as possible. So, databases.
Yeah.
I mean, the big thing with databases is you're never going to be able to tune SQL with databases, and Oracle and Sybase both are going to be way better at being able to report suboptimal SQL, and you know the cost-based optimizer in Oracle is pretty amazing, and it can tell you where execution plans are going wrong and all sorts of stuff. What you're going to be able to do with dtrace is be able to find an interaction between the database and the system of the database and going off in terms of talking network or anything else, where the potential problems lie. And there's no Oracle database that you can look at that there's not something that you can affect in the database by changing something in the system, just because of the heavy dependency, the amount of I/O that it does, networking, scheduling, all these different things.
So, Jared, you're rarely reluctant to voice your RFPs, but what are the places you might see dtrace be enhanced to help you with your data?
So in terms of best places to be enhanced is the ability to do what we're going to be able to do in JDK 7 does, which is to be able to do probe points for which nothing allows in this process to start, be able to pick those up, right? Which I think would be doable with some changes to the linker.
So you're referring to JProbe, or are you referring to
The Java probes,
Yeah.
JSDT.
Yeah.
So that's pretty nice. I can do a JSDT every time I kick something off in Java.
Yeah,
Because there are a lot of systems that still are fourth exec based, or worse, started from somewhere else, where applications come and go, and then you have the monitoring problem and the brand short-lived. It'd be nice to be able to instrument and see exactly what they're doing.
We've got all of that.
Yeah.
Startup costs on large systems?
Well, that's the cage. But yeah, so just the Alex storm that the cage sometimes disagrees with.
Yeah. So the issue here is that we are allocating buffer space for dtrace, and we allocate buffer space on a per CPU basis. That's in kernel memory, and on these very
on a 128-way system.
128-way system with how many? With terabyte, 512 gigs. Yeah, have a half terabyte of VRAM. We support hot plug with VRAM, and so there's a kernel cage where you want the kernel to reside in specific memory banks effectively. That has to be changed dynamically. The kernel does not do well with service and memory allocations, and it's a tough problem. We wanted the KM, not KM sleep, but what was the flag? We had it.
Yeah, we came up with a flag name. KM Nodal.
Yeah, KM Nodal. Yeah, Jonathan Adams, where are you?
Oh, wait a minute.
Yes.
Is that the one where it's sleep-like semantics but without sleeping?
Yeah, that's right.
What is
Yeah.
that?
You need it too.
If you're going to have to do any work to make this allocation
right.
succeed, don't do it.
Yeah, right. Like I want some memory, you gotta lie around and give it to me. Because the other problem is that dtrace will dtrace reacts very well if it's out of memory. It will start halving its buffer sizes. So you may have seen this if you run dtrace and say buffer size reduced to megs. And unfortunately, I can't get that feedback right now because I've got to do KM no sleep allocations and watch those KM no sleep allocations fail. And those KM no sleep allocations, unfortunately, I don't know if it's the same way. Steve, you guys have similar semantics in Mac OS 10 in terms of sleeping allocations versus non-sleeping allocations. And you got no way of differentiating a non-sleeping allocation, like I need this or I'm going to die. Right? And the system is going to, so on a no sleep allocation, we try very, very hard to satisfy it. Too hard.
We need like a KM no sleep or KM I don't really care.
Yeah, we do KM Nodal, I think.
KM Nodal.
Yeah.
Which is if you have to do any work, if you have to expand the cage, make relocate, anything, I don't want it.
The whole networking subsystem would benefit greatly from
No, I
this
think-
because packets drop. We don't mind if packets drop, really.
I think we strongly agree that Jonathan has taken this in.
So what
No.
about pre-allocating on, I got monster system, I got half a terabyte of RAM. At boot time, pre-allocate some 4 meg per CPU and give me the switch to turn that off if I want to. And then on the big system, I don't pay that cost.
You can definitely do that, but ultimately that's a band-aid for the fact that there's not this semantic information being expressed to the CAN layer. So apparently I've got to do more than convince Jonathan to go with this. But,
Have you filed a bug?
I have filed a bug. Cool. Great, Jared. Thank you. By the way, if you're ever looking at Sun's marketing collateral around dtrace and it's seeing you found X thousand % in under 30 seconds, that's the man who's always done it. So I have to say you don't just no offense, Jared, but Jared's from West Texas. Maybe you think, maybe he's exaggerating a little bit. Until you actually sat with Jared and watch him find one of these things, you won't actually believe it. Jared credits dtrace, but it's actually it's his own intuition for the systems and yours as well. Put this room in the same way.
That's the great thing, that dtrace enables your intuition to follow its path.
That's right. And for someone with intuition like Jared's or yours, it works great results. So Jared, thank you again for all you've done.
First, definitely try to corner Jared and get him talking about anything you're going to talk about, especially World War stories, because I know this is just the tip of the iceberg. The other thing is, point on the wireless network. At Fishworks here, we have the worst DSL network ever, so please don't upload stuff. We have colleagues in the other room who are trying to do interactive sessions elsewhere on the internet, so if you can avoid uploading, we would really appreciate it. Thank you.
And unfortunately, we're not running dtrace on our Cisco router yet. Otherwise, we would find out who you are and actually yank your laptop. That's right. Well, actually, no, yeah, it's funny. We need to go build a router.
We'll share. All right. So Alex, you go.